Alright, you guys have a post test today, so make sure you pay really close attention. Ask the sub to pause if you need it. Make sure you're writing stuff down and asking questions if you have them. Your test today is going to be on graphing, both linear and nonlinear functions. Doesn't matter whether it's linear or nonlinear, it's still the same process for all of them. So the three that you see right now are pretty common ones. The only other one that you might see on your test is something with an x squared, which just means you square the number. Okay, make sure you show all your work, label your x and y axis numbers, and do your math very, very carefully. Alright, let's first example together. So we have y equals 4x minus 2. Now, in this one, they put the 4x minus 2 in front of the y. It doesn't matter. You can switch it back if you want to. So it's y equals 4x minus 2. You will always use these 5 numbers listed above, -2, -1, 0, 1, and 2. What you're going to do is take each of them and replace the x. So 4 when x equals -2. That gives us that y equals 4 times -2 minus 2. Well, 4 times -2 is -8. And -8 minus 2, because they are same sign, you add and take the sign, and that equals -10. For the next one, x equals -1. That gives us y equals 4 times -1 minus 2. Well, 4 times -1 is -4, and -4 minus 2 is -6. The next one, x equals 0. That gives us y equals 4 times 0 minus 2. Well, 4 times 0 is 0, and 0 minus 2 is -2. Now, this is a linear function. Okay? The x is only being multiplied and or added. There's no exponents, there's no absolute value, so that means it's going to be linear. So we can follow the pattern. So to go from -6 to -4, you're adding, or excuse me, -6 to -10 to -6, you're adding 4. -6 to -2, you're adding 4. So from there we can continue to add 4. So that gives us -10, then -6, then -2. The next one, -2 plus 4 would be +2. And then 2 plus 4 would give us 6. Okay. Now, on this one, I have pre-labeled dots. And I shouldn't have put that because I've run out of space. So, that's the beauty of you guys, and you're able to make it what you need it to be. I'm going to adjust this one, but you, as I mentioned, can make it what you need it to be. And actually, I'm going to pause the video quick and I'll get a new one that will allow us to do all of this on the same graph. Okay, so now I have graph that goes from -10 to 10. Now you wouldn't need it to go from -10 to 10 on the x values, you'd only need it on the y values. So yours could be skinnier if you'd like it to be. So my first point is -2, -10. So I'm going to go left 2, down 10, and put my first point. From there, my next one is -1, -6. So I'm going left 1, down 6. Next one is 0, -2. So I don't go left or right at all, I just go down 2. Next one is 1, 2. So I go over 1, up 2. My last one is 2, 6. So I go over 2, up 6. After you have your 5 dots, you connect, extend, and draw your arrows, and it should form a perfectly straight line when you know it's a linear function. So I connect, extend, and draw my arrows. A little harder on the iPad, but you, on your graph paper, should make a fairly straight line. There are rulers at the front of the room if you want to make it perfectly straight. Alright. This one is nonlinear, and we know it's nonlinear because there's something else around the x, and in this case it's an absolute value. So for this one we can't cheat and only do 3, we have to show our work for every single one of them. Still the same process. So that gives us y equals the absolute value of negative 2 plus 3. Absolute value refers to distance from 0, and negative 2 is 2 spots away from 0. So this becomes 2 plus 3, which is 5. For the next one, y equals the absolute value of negative 1 plus 3. The absolute value of negative 1 is positive 1, and 1 plus 3 is 4. So we fill in 4. The next one, y equals the absolute value of 0 plus 3. The absolute value of 0 is 0. 0 plus 3 is 3. Now at this point, you might be thinking that there is a pattern because it's going down by 1. But you have to be careful because you should know that this is nonlinear because of the absolute value. And watch what happens on the next number. So that gives us y equals the absolute value of 1 plus 3. Well, 1 is 1 spot away from 0. So the absolute value of 1 is still 1. And 1 plus 3 is 4. So if it followed the pattern, it would go down to 2, but it doesn't. It goes up to 4. The next one, y equals the absolute value of 2 plus 3. Absolute value of 2 is 2, and 2 plus 3 is 5. Okay, now we're going to plot those points. So the first one is negative 2, 5. So you go left 2, up 5, put a point. Next one is negative 1, 4. So we go left 1, up 4. After that, it's 0, 3. So we don't go left or right at all. We just go up 3. The next one is 1, 4. So right 1, up 4. And then 2, 5, so right 2, up 5. Now you connect them in the shape that they're creating. So on the left, we draw an arrow through those, connecting those, extending them, and drawing the arrow. And then on the right, we'll connect, extend, and draw our arrow there. An absolute value does make a V shape every time, so that's kind of a way for you to know whether you're correct or not. All right, let's look at the last example. Okay, so our last example here is y equals x to the third power. X to the third power means you're taking whatever the x value is times itself 3 times. That's what a third power means. So for the first one, we have negative 2 to the third power. Now that will give us negative 2 times negative 2 times negative 2. If we broke it down piece by piece, negative 2 times negative 2 is positive 4, and 4 times negative 2 is negative 8. So be really careful with your positives and negatives. The next one is y equals negative 1 to the third power. Well, negative 1 times negative 1 is positive 1, and 1 times 1, or 1 times negative 1 is negative 1. So that equals negative 1. The next one, 0 to the third power. Well, 0 times anything is 0, so 0 times 0 times 0 will give us 0. On the next one, y equals 1 to the third power. Well, 1 times 1 times 1 is 1. And our last one, y equals 2 to the third power. That's 2 times 2, which is 4, times 2, which is 8. And I have the big graph paper on this one as well because I knew I needed it. So I'm going to plot my points. The first one is negative 2, negative 8. So I go left 2, down 8, and put a point. The next one is negative 1, negative 1. So I go left 1, down 1. Next one is 0, 0. So it's right on the origin, right where the x and y axis meet. The next one is 1, 1, up 1, over 1. And the last one is 2, 8. So right 2, up 8. And then once again, we connect our dots in the pattern kind of that it's making. It's not a connect the dot, kind of swooping through and hitting the points along the way. So I'm starting down here, I'm swooping through and catching them and continuing off in that direction. Okay, I refer to this x to the third power as an essy, snaky, typey thingy, which is kind of what we have created here. Another way to check your work. Okay, just to kind of review the general shapes quick before you go to your test. Anytime x is just multiplied divided, added, subtracted, one of the four or multiple of the four basic operations, it's going to be a straight line, okay, also known as linear. If you have the absolute value of x, it's going to make a V shape. If you have x to the second power, it's going to make a U shape. And as we just looked at, x to the third power makes an SE snaky typey thingy. So please be thinking of those shapes when you go to graph it to make sure that you did it correctly. Take your time on your test. Make sure you show all of your work just like I did over here. Take your time, write it out. Good luck.